Luke, I am your father. No? Yes? Okay. I'd like to observe a moment of silence for Chewbacca. Anyone? Seriously? Okay. So let's dive in. I'm not going to summarize on the theory that you all have heard a ton already. And we're going to jump around in terms of the seating arrangement. But the first speaker will be Brent. And the sort of questions that we're hoping Brent will get into will be the notion of what this right to explanation might even look like. And specifically, he's been doing with his colleagues work that I'm very excited to see about counterfactuals, which came up in one of the panels. And actually, interestingly, someone had I don't know if that's going to work. So that's always fun. And with that, I'm going to shut up and say all yours.
OK. Well, yeah, thanks so much for inviting me. So the last panel, I think, was really interesting and really got into what a right to explanation could look like. So I'll touch on that briefly, but I'll focus a bit more on counterfactuals. And let me just say it's been really fantastic to see sort of how that debate has moved on from a couple years ago when Sandra and I were writing about, the first paper that was on it, saying that it wasn't there in the law. So it's really interesting now to see both how it's being interpreted in terms of what a good explanation looks like, but then also how member states and states outside the European Union are sort of putting things into practice that look like a right to explanation or different flavors of a right to explanation. So that's fantastic. I think I'll pick up on something that was definitely covered in at least one of the panels earlier, which is, of course, a right to explanation is going to depend a lot on what the question is that you're asking. What's the purpose that you're asking for an explanation for? And I'm going to set aside the issue of explanations as a precursor to justification. I think maybe we'll get into that more later in the panel. I think it poses a separate set of issues from an explanation that is somehow seeking to explain the behavior of a model. And so for me, within that space, there's two different types of explanations you can talk about. There's basically an explanation that's responding to the question, does the system work as intended? Does it work as I built it to? And also, what about me or my particular case do you not like? So what did I do wrong? Why did I not get the thing that I was asking for? And so the work that I've done on counterfactuals very much addresses the second type of question about what it is about my particular case that led to a particular outcome. For me, it makes a lot of sense in that space to connect the right to explanation to the right to contest, which is to say that for the right to contest to actually be meaningful, then you need an explanation that provides you some crucial information so that you can start to explain why you think the decision about you was wrong, or at least to question certain aspects of it. And so one of the things that I've been particularly interested in is to see, both from the computer science and machine learning community, but also from the legal and ethical side, is whether there are sort of new methods being proposed to actually address that question. So to address that question of how do I give you an explanation about your particular case that will give you some of the necessary information to actually contest. And so that's essentially what the notion of a counterfactual explanation was designed to do. It was designed to tell you something specific about your particular case. And so one of the questions I was asked to address was sort of why would counterfactuals be useful for a right to explanation? And to me, counterfactuals are useful for those sorts of situations where you had a different outcome in mind than the one you received. So the sort of example that we use in the paper is that you applied for a loan, you didn't get the loan. Obviously, the outcome that you had in mind was that you wanted the loan. And so a counterfactual explanation would tell you something about what would have needed to be different about your particular case in order to get the loan or to get the outcome that you had in mind. I think there's some other things, though, that counterfactuals can help with. They can reveal how your classifier behaves poorly or in unexpected ways. They're very similar to adversarial perturbations, which will show sort of how an image classifier breaks, where what's the sort of noise that you have to add to an image in order to flip the classification from, say, a dog to a chair. They can also be very useful to point out when data about you has been incorrectly recorded. So again, with the loan example, if you receive a counterfactual that says your income was $15,000 pounds I'm going to do. If your income was 15,000 pounds, you would have received the loan, but your income was 10,000 pounds. But actually my income is let's say 30,000. I can tell from that something about me has been incorrectly recorded. And I can go back to the data processor, to the data controller, and say, hey, I think you actually hold incorrect data about me. And then the last thing would be that they can reveal when potentially unjustifiable features have significantly influenced a decision. So if I receive a counterfactual back that is based, say, on my ethnicity, and I think that using ethnicity is unjustified or illegal, I can go back and say, hey, why did this actually feature in the decision? Why were you using it in the first place? And it doesn't just have to be illegal features that you start to question in that regard. It can just be things that seem abnormal or unintuitive in some way. And I say potentially unjustifiable because, let's say, the fact that ethnicity was used in a particular decision doesn't necessarily mean that it was used in an unjustifiable way. It's just the start of a conversation. And I think I'll just sort of wrap up my initial comments here by just sort of touching on a couple of the let's say, limitations of counterfactuals, and I'd argue actually limitations of explanations in general. One of them is that counterfactuals, by definition, can only deal with features you've observed. So whatever data you've actually provided for the decision, we can only deal with those sorts of data or features and the relationships between them. So there will definitely be external mechanisms, external relationships that are outside of that observed space where you couldn't possibly predict those within a counterfactual. So let's say, for example, if I say you needed to have 5,000 pounds more income to have gotten the loan, you did that, but then you also bought a second car when your income went up, and I didn't actually observe car ownership, then obviously we can't predict that influence on your life. But I would actually argue that that's a limitation of any type of explanation, not just counterfactuals. And so for any of the relationships within the observed space, you can actually deal with those in a valid way. And then I have a bit about sort of whether explanation methods that are based on, that require interpretable features are a good idea or not. But I don't know, are we going to get into that later, or should I address that now?
Well, I'd actually like to make sure first we get a few people to respond and then hopefully circle back.
Okay.
So anyone on the panel, open season, let Brent have it. I'm just kidding. But responses, thoughts, counterfactuals, working, not working, and if you don't, I'll jump in.
Jump in.
Okay. So at one level, a simple version, correct me if I'm wrong, would be, this happened to me actually just recently because our school switched to a system I hate called Canvas. And luckily, I kept looking at my own spreadsheet versus what they were saying, and I kept getting weird numbers. And then one of my friends reminded me, why don't you just put in zeros for some of these, and you'll all of a sudden see what was going wrong. It was the wrong data issue in terms of, and it actually revealed a problem in the formula that the online version of the grading system had versus mine, and mine was the one that was correct. But students see one thing and they get very upset. Very simple version of that. But I think the bigger questions then is, what would be the counterfactual, and maybe it would be a different limit, I'm wondering what you think, is college admissions. So the big case recently having to do with UT Austin, or the Harvard case, right? Which is, my version of this is sometimes, but there's another part of this, which is there are roughly 1,000 fungible, from the view of the admissions office, for every seat, at least in terms of pure numbers, and possibly in terms of race. So what's the counterfactual, right? The kid who got into nowhere except for Duke, by the way, which is really not a shabby place to be, but okay, you didn't get the brand. So I'm just curious, in that situation, is counterfactual, am I missing how it may or may not work? Because that would be his question is, well, in this situation, you might have gotten into Harvard, but the actuality is, dude, you had everything, but it turns out, for whatever little reason, you didn't look that different than anyone else, and we said no across the board. I'm curious.
Well, I think in that case, whatever that little difference is that led to you not getting in, that's the thing that the counterfactual should be able to flag up to you. Now, that's not going to tell you, I mean, it's not going to tell you about, say, the profile of all the other people that got in and how you compare to them. But if it was, if I'm understanding the problem correctly, if it was also just sort of we have 100 people that are possible for this one position, so we're just going to randomly choose somebody.
Right, there's the subjectivity factor, which is in the play here, right? So you can imagine software that said, hey, these people all made that first cut, but we're never going to be able to, I think, Harvard's certainly not going to be able to really articulate other than the dark things that came out, but as pure numbers, there's still a ton of, hey, it turns out we still have a lot of East Asians coming. So for this one kid, what could he have done differently? You know, happen to be the other kid, or happen to have someone read his file on a better day?
Well, yeah, that was going to be my next question. Is if we're talking about a system here where essentially the decision seems to have come down to some sort of human randomness or human judgment, then you're talking about a counterfactual with a system where a big part of it is
so there's your wall.
Human involved. Well, yes, but I suppose that again, I think that's going to be a problem with the methods of explanations we have already.
Absolutely.
So
yeah.
Yeah.
Okay. Fair enough. Then what we had originally, Tom, if you don't mind, then do you have a sense then of what might be ways to build things that would get to these questions of accountability or explainability from a CS perspective?
So in the CS department, I have experience and pleasure to educate many upcoming so-called computer scientists. And I want to, I will start off with a math question for all you guys, so you stay awake and to wake you up. And so this is a math problem I'm helping my 8-year-old son with. So there are 12 apples, and we would like to give them to 3 children. How many apples does each child get? So what do you have? It depends on how many. So if you're thinking 4, I think that's probably the right answer, right? And so, so you unpack this experience that very, very few people would question that, why do we have to distribute those apples fairly across 3 children? Another question is, why only 3 children? Can we share them with 12 children? And so what actually struck me is that, so there is some kind of reckoning in education, especially in the STEM, engineering. So we've been training our kids to problem solve, to react to problem they encounter as engineer, to just solve it right away without question, why do we have to solve it in the first place? When we asked to build a personal music recommendation system, you just build it. And so it's amazed how many programming assignment I can give to my students. They will question, why do they have to write a piece of program? And so one of the reasons I think we end up here discussing about explainable AI is that there isn't a lot of training experience built in on the demand side. Like people demanding, asking why question in engineering discipline. Why do we need to build this? And what's the reason I have to write the source function in the social context? So there's been a focus on abstraction in computer science education. So everything's being abstracted out. It's 12 divided by 3. It's not 12 apples shared by 3 children. So the one thing that so we have a discussion, my reflection about things going forward is that we probably need to make a more effort in our engineering computer science education curriculum to teach our students to, first question is to ask why when you are given the programming assignment. And then to create a demand for why. And then there are more people asking about why it has to build this way. And they will drive that on the supply side. And then we'll be able to be more motivated to provide better explanation. So in the fields like art, when we're being asked, I experience asking kids to draw a tree, for instance, in art class. Then you tend to get these responses. Why do I have to draw a tree? Can I draw a horse? Can I draw my pet? So in the engineering, so that I hope that that's going to be something we could enable to give students a bit more experiences to have deeper reflection about why one's handling the problem. And so one of the innovation in computer science instructional method has been peer programming. The notion of giving the programming assignment instead of putting 1 programmer, but putting 2 programmers. At first, it's very counterproductive. It's just way more cost in software development. But it turns out that study after study has led to fewer bugs. And also led to, the reason is that in a peer programming environment, 2 people have a lot of chance to talk about stuff and talk over their code, talk over their logic. So that is actually explanation of computer science. So explanation in the bigger sense. And in that case, that's where there are more opportunity to explain, that you are forced to explain. And in the longer term benefits that lead to a better way to document and better way so they'll feel more motivated because they've received those training experiences in the undergrad curriculum. They know that they need to better explain their certain decision. So they explain computer science. So in my opinion is that if we spend more emphasis on teaching our students how to talk about their programming, talk about the rationale of a particular programming assignment, why do they have to work on it in the first place, and that will have an effect of, if they work on the AI, they will probably apply that sort of experiences to AI as well. I have to explain my code. Now I'm building an AI system. I just download this Python AI module somewhere to do voice recognition or face recognition. I'll ask why. Why do I have to use this system? How does it work? I want to be able to explain that as well. And so my colleague and I have been trying some new things in this area, and then we'll have these two principles that we believe are pretty important. So one would be to teach our students early about explainability, and two is to be integrated into a particular curriculum. When you teach on intro programming, when students need to write a conditional statement, if and else, and this is where we should raise the issue of explainability. Explain why this decision, a condition is an example of making a decision. Explain why this decision has to be made. Explain is it going to lead to a fair or unfair outcome. Explain that this is what the input are they coming from personal data. So if they get practice early in the area, perhaps in the third year curriculum they encounter AI, they will be more ready and more willing to think about explanation and in an integrated manner. And so that is my take in terms of going forward. So the question I receive is that what as a computer science or programmers we need to build. I think in terms of talking about this concrete system solution, I will feel there's an urge for me to comment on about a bigger picture of the way we should rethink the way we train our next future generation of computer scientists we're gonna put in front of important problems. I hope that my vision is that we'll be asking why we have to build this rather than how much time do I get to build this, or what kind of programming framework do I need to use to build this.
Anyone on the panel? Because I definitely have some.
Sure.
Yeah.
So I teach at a school of information, which is an interdisciplinary professional school. I teach master's students, PhD students, and then more recently I've been teaching in our undergraduate data science curriculum across campus. And one of the things that one of the classes I teach is Behind the Data, Humans and Values, right? And it's undergrads, upper division generally. And it's been super interesting, for me to help them do what I think other parts of computer science do incredibly well. So if you think about like interaction design or design, they care tremendously about the edge cases, right? Whereas machine learning, it's all about kind of smoothing everything out, right? And so not thinking about kind of the people behind or the distribution or whether or not the phenomena you're looking at is actually going to be evenly distributed across the population or if it's going to manifest differently. And a lot of it has been about kind of introducing things that I think are like basic tenets of social science research into the ways in which computer scientists think about data, its relationship to information, knowledge production, system design, things that Maria was raising earlier, assumptions and limitations, how you operationalize your construct, right? Mm-hmm. And one of my favorite examples, everybody likes to beat up on the Facebook emotional contagion study, but one of the things that I really like to do with it is have the students actually, one, I get to teach them about A/B testing, but I also walk them through the way in which the researchers decided they were going to look at kind of the spread of emotions. And you know, if you were trying to look at how emotions were spreading on something like Facebook, what do you, well, they look at the text. They analyze text. And of course, like when you think about the ways in which people communicate their emotions on Facebook, so they ruled out pictures, they ruled out emojis, they ruled like all of these things that I think we would view as incredibly important if you were trying to measure something like emotion. And so the way in which they kind of constructed the variable that they were actually going to look at, the performance metric, was bizarre, right? And so just going through that, like setting aside all of the kind of ethical issues, just as an experimental design question, right, it becomes incredibly powerful. And so I think one of the things that I found really useful is taking studies and unpacking them as a way to help students understand the limitations of the data, issues about how they're, you know, constructs, choices of models, all of these things I think are really, really important. And I agree with you, it helps to facilitate kind of a culture of questioning. It's not just, oh, it's some data, let's suck it in, as somebody was talking about it. It's like toothpaste, just squeeze it, it comes out, right? That it's data about people, it reflects a certain, I love the word CAPTCHA, right? It actually, it's not data, it's what we've decided to collect. And just introducing all the issues about whether or not we can actually measure, does the thing we're using to measure work equally well on different populations, all of those issues have been really important.
That's actually a great bridge. And forgive me, I forgot to ask, how do you pronounce your first name? Is it Diaria?
Diarra.
So Diaria will now talk about some very cool stuff. And this is one of those moments that seems to happen to me at Georgia Tech a ton, where it's like, wow, we work on the same campus, we should hang out more. So there you go.
So my work is in social robotics and robots that are specifically designed to interact with humans in mainly rehabilitative scenarios for children with motor and cognitive impairments. So one thing that we need these robots to do is to be able to communicate. And a huge part of human communication, and humans tend to project the way they interact with humans onto the way they interact with robots, a huge part of that is the ability to communicate informationally as well as persuasively, which is hugely correlated to explanation. So if the robot says something, gives a command to a child, and they ask why, and if it can't answer that, that leads to distrust in the system. And trust is a huge thing in human-robot interaction. That's something we really care about, because if they don't trust the system, they tend not to follow the instructions. It tends to have an adverse effect on the performance metrics that we really, really care about. In many of these robotic systems, they're making many decisions behaviorally. They're choosing choice of words. They're analyzing perceptual information, whether it be images or sounds. So it could be several models working together that each could have their own explanation process. But what really matters when the robot is interacting with another human is how it kind of puts all that together. So the low-level extraction isn't as important. I don't necessarily need you to explain to me that there was a 30-degree angle in between my top and bottom lip, and that let you know I was smiling, and then that made me and I'm happy. But the saying that I thought you were happy, and that led me to do this, and so I responded this way, and that's very beneficial, especially for children who have trouble in interacting socially, and that's one of our main focuses. So thinking about that, and then trying to make these high-level abstractions and connecting the ends of the network that mainly make those huge decisions. And that's what's we find really important and really informative. And several studies have shown that when children or adults or anybody working in these human robot scenarios, when they trust the system, when they understand the intentions of it, when they say, oh, okay, I kind of see what it's doing, I trust it more, I don't think it's going to do something that I'm not expecting, it's explaining what it's doing to a certain extent, and I trust it more, and that maximizes outcomes, which is what the overall goal is, especially in rehabilitative scenarios where we care most about the kinematic performance, the trust in the system, their intrinsic motivation to keep going and to continue going over time. So looking at those things over time is definitely important, and that's how kind of explainability kind of works its way into human-robot interaction, which has been getting a lot more attention lately.
Other comments and questions? 'Cause
It's about children, so I think I would like to jump in. I have two children. I have 1-year-old and 7-year-old, and it's about 6 years gap if you do the math. And it's amazing that 6 years already create a generational gap. So my 7 years old is swiping on everything kind of generation. Every flex surface, he will just swipe on it as a kid. And my 1-year-old is everything looks like this, he will speak to it. And so it's just like our relationship, our children's relationship with the water bottle. I mean AI is just like is something that we require our society to think harder about. And so there are, for instance, the issue of, I have this anecdote of being at a conference, at a human robotic conference, and they're reporting the result. And one of the quote they reported is the child reported that I feel robot is smarter than I am. And so it begs the question of, maybe it's a good thing. So it motivates the kids to learn more and be smarter than the robot. Or maybe it's a bad thing. And so a question was raised by the audience about some ethical implication about the statement. And so the response is, I'm just an engineer. So that was the response. So it shows that, so there's definitely a bit more work about bridging the gap between engineering and ethicists and social scientists and the interaction designers and so people in different fields in the same room to address this issue together. And so the engineer, we should not work in isolation to trying to tackle the issue, or trying to just kind of take a back seat and using I'm just an engineer as an excuse not to care about it. And so in terms of explainable AI, and so there's a question we have to ask: how do we even explain to my child that it's not a robot, it's not AI, it's a water bottle? And so like in the car, for instance, this in the world, we have to explain to my child that certain behavior, going outside, you should not play on the street. Why? Because there might be car running by. That's not inherent danger. As good as convenient as useful cars are, there are also some inherent danger that would have to communicate, explain to the kids. Don't get in front of a car, and hold a flag if you're going down because you are too short for the car to see as you walk to the school. And so what is it? So what would be our responsibility as parents for our young generation with respect to their behavior in the world of AI? So should I tell my kids that you should make sure you bring your sunglasses when you walk outside and put them on so that the surveillance camera wouldn't pick you up with face recognition and so on? So this is something I want to do. And so this definitely we need some deep discussion about this sort of explanation.
But there's a slight difference, I think, in some of what you're saying and what if I'm not mistaken, what I was getting from your explanation was a little bit of maybe a whiff of the counterfactual moment of maybe I'm overthinking this, but it was because I saw you smile. Mm-hmm. So it's actually a little bit deeper about what is happening. And that's why I thought it was an interesting bridge from where Deirdre was talking about is, a little sensitivity to here's a very simple way to know, and I guess it reminds me a little of something that's been unsatisfying is why did I see this ad, right? But it sort of gives you a clue. And in theory, it was meant to, and maybe it does engender trust with people who are looking at it. But these, to me, are interesting little moments where you could almost also get involved with a quick change on whatever your input or position was, right? As you're an adult, you allegedly change the data on the why I saw. And with a kid, there's this moment of, oh, well, okay, I get that. And of course, on the slightly dark side of this is, now you're training people to modify behavior to a certain set of rules that, again, we might want to, shall we say, contest?
I was going to say that was a good bridge. I like that. Very well played. So I want to shift the conversation a little bit in that I think explanations basically suggest a very particularized kind of arrangement of humans and machine learning systems. They are going to act in ways, and then they're going to explain themselves to us, and then maybe we can contest them. And I actually don't think we ought to assume that that's the right way to arrange the world, right? And in particular, I think we're seeing machine learning systems being introduced into really high stakes decision making, where historically we have relied on deep professional judgment or agency expertise. And one of the things that I think we need to be attentive to is to make sure that the introduction of this new work practice, right, which is really what we're talking about, doesn't disrupt the logics of knowledge production that may be professional or maybe institutional by mistake. And I think that is a lot of what we're seeing. And so what we find happening is that systems are acquired without attention to how they align with knowledge construction, reasoning, decision making. And part of this is about the acquisition of systems. And I think that, Andrew mentioned that, yes, I think that administrative law actually has a much larger role to play in the public sector. But that also things like algorithmic assessments may be a really useful tool at acquisition time to help us make sure that the tools that we're using align with our domain-specific commitments, right? Because if they don't, just like any other tool, we really shouldn't be bringing them on board. But I do believe that part of it is also about the ways in which we construct the systems themselves during runtime so that they can support and enhance very domain-specific ways of knowledge production. And knowledge production is a process, it's not just an output, right? And so for me, I think that there are kind of two goals that we ought to be looking to support in introducing machine learning systems into work practices. And one of them is that there really are things that machine learning systems do better than we do. We're really good at remembering people we know and seeing them in a crowd, but we're really crappy at remembering whether or not we've seen all the people we didn't know right after the fact. And I'm not suggesting that therefore we should have massive facial recognition systems. That was not the point, right? but that we do different things well, and I think we ought to actually be looking for ways and opportunities to leverage the specific things that machines do well, right, that are distinct from what we do well. But importantly, that I really like this phrase that comes from a piece by Judith Simon about distributed epistemic responsibility, that I have taken and said, I want systems that are introduced in a way that they result in epistemically responsible knowledge production, right? And that means both kind of attending to the conditions under which people are working with machines and attending to the kind of governance models through which we acquire those machines. So in that kind of what does it mean to engender epistemically responsible knowing, right? I'm assuming epistemology is an okay word to introduce in this group. I think this idea of contestability rather than contestation is really important. And contestability comes from some work by Tad Hirsch. She's an interaction designer. And it's the idea that what we want to be able to do is actually interact with the way in which the machine is reasoning in real time, not just be served up a result and then have to contest it. And you can look at, there were some regulations that were proposed in the healthcare context for clinical decision support systems by the FDA that I think kind of step in that direction, right? And they basically say that if doctors are relying on these systems, they need to understand the data that they were trained on. They need to understand whatever clinical guidelines are built into these systems. They need to be given information that might look at kind of distributions or probabilities. And they also need time to reflect, right? That it can't be a situation where they're asked to act quickly if it's going to be considered kind of a decision support system. And so there's more of a interrogation, right? Because we know that the human is going to have different access to different kinds of knowledge, right? One of the reasons that we allow professionals, for example, discretion is that we understand that even if we think that we've thought about every piece of information that might be relevant to a decision, in that particular moment, there might be some new information that becomes really important. And a machine learning system is really good at considering the information it has, it can't actually consider information that isn't part of stuff that it was supposed to be ingesting to begin with, right? And so I think there are real reasons to think about contestability rather than explainability if the goal is kind of responsible, domain-appropriate knowledge production. And so that is the thing that I'd like to bring to the table.
We have good timing, yeah, please.
Yep. Well, I totally agree with the first point you made, that one of the problems that we have with explanations now is quite often they're portrayed as this situation where a machine does something to you and then you receive an explanation of why that thing happened, and then that's the end of it. And in Tim Miller's framework that we were discussing earlier, one of the sort of key features of what he says a good explanation would be is one that's social, which it's a two-way exchange of knowledge. And also it is selective, which means that maybe you get one explanation, you're not quite satisfied with it, and so you ask for a different explanation or different questions. And so I think sort of using that model going forward is exactly right. It's one of the reasons that we're thinking of counterfactuals embedded in some sort of API where people could basically generate their own, and in that way sort of interrogate the system. But I also worry that that portrayal of the interaction between machine and person and how explanations just flow one way is one of the reasons why we're starting to see some backlash against explanations, in the sense that it's very easy to get frustrated by explanations if they're dealing with features that are not human interpretable, or if they are just offered to you in this sort of one-way street fashion. And I think we should be very hesitant about actually abandoning the idea of, we should have an individual right to explanation, or we should, at least somebody should be able to explain how the systems are behaving, because that's so fundamental to how we justify things to each other, how we decide what is the right course of action. I mean, this is basically how we have justified things to each other, for our entire existence. And to say, to basically say, well, actually you're using data that is not human interpretable, therefore you don't need to provide me an explanation. That sets a really, really dangerous lesson for industry, where basically collect more complex data and then you don't have to justify yourself.
Oh, sure. I'm not at all suggesting
Oh, no,
that.
I wasn't suggesting
okay.
you were. Sorry.
And for me, this concept of contestability, I think I've been really focused, a kind of touch or a jumping off point was the Loomis case, right, where I know almost all of you have probably read the Loomis case or you're familiar with it, but it's a case where a risk recidivism tool that's supposed to be used at the bail stage was used during the sentencing phase. It gets challenged. It goes all the way up through the Wisconsin Supreme Court. It's they file a cert petition in the U.S. Supreme Court. And the thing that galls me is that the Solicitor General for the United States writes a brief saying, no, we shouldn't take this case, in part because the issue of gender, we can't really, it's not really reviewable here because it hasn't been teed up right, because despite the fact that it's gone through all of these processes, we have no idea how it's being used, right? And that just galls me, right? Like, it's a system that was pulled into the system of justice, and you don't know how gender is being used. It's not part of the public record. It wasn't debated. It wasn't the subject of reasoned decision-making. And maybe it was, but clearly there wasn't enough transparency around it, enough deliberation. And I think this goes back to the both justifications and kind of reasoned decision-making, right, that we actually need to be able to interrogate. And I think it was interesting both that the system was adopted without necessarily a lot of attention to how information was being used, what data it was trained, et cetera, et cetera. But I also think it was really interesting that the question of whether or not professionals who might be told to use systems accept or reject them. And there's some really interesting research by people using kind of more ethnographic methods that suggest, like all work practices, people aren't like, oh yeah, slave to the algorithm. Yeah, there's automation bias, but there are some communities, and judges, for example, not so keen on being told what to do, right? And whether or not kind of professional role and particular kinds of regulations might promote more responsible cultures of algorithmic use.
Right there, I'm going to stop you because that's
Yep.
a perfect bridge to Mr. In-house lawyer, how do we do this?
Yeah, well, got it all solved. No, the
No,
it's
but
sort of-
truly, I think, just to be clear, I think Deirdre's tearing up something
Yeah.
that's totally your wheelhouse about exactly what sort of world when you're inside a company
Yep.
and or outside and you're either selling a software or saying, hey, we should adopt this, the reality check, if you don't mind.
Yeah, exactly. Well, and I think the reality check, I mean, this conversation, I think, puts it very accurately in describing the need for this broader culture of questioning. Tom and I had an interesting conversation at lunch when we sort of were talking about the way that the computer science discipline today is broadening in probably early stages to start thinking about some of these ethical sorts of issues. And I think transparency, explainability is fundamental to that. And the conversation had to do with, what are the right elements of training as you think about the developers of the future, the people who will be building machine learning systems going forward. What is it that they need to understand and learn? And I had this sort of aha moment as I was listening to that and thinking, this is precisely what we're doing sort of on the other end of this right now today within the enterprise, within the corporate environment, where we don't have this long history of tackling these sorts of issues in precisely the way that we've been talking about today. So in a very similar way, we are re-educating, in a sense, our own sort of corporate environment to think about these issues and address them pretty broadly. Sort of the question of, how do we tee this up? If we as a developer of technology or as a user of technology have to begin tackling these issues, how do we do that? I think the answer is it really begins with a fundamental mind shift that ultimately is we've been spending quite a bit of time thinking about how we operationalize these concepts, and in particular, how do you operationalize a notion like explanation of AI? It sounds great, and we get that it's important, and there are lots of people who talk about this as a fundamental principle, but then you've got to go turn that into real engineering practice. And you do that in an environment which I think traditionally is sort of geared towards speed, moving quickly, first mover advantage, being able to address customer needs and do so comprehensively. And so there's this tendency to want to say, well, just give me the tools, give me the solutions. I need to check my system for fairness. Great. Where's my tool to check my data for fairness? And of course, that fundamentally it illustrates, I think, this exact problem as Tom was illustrating. There's got to be this culture of questioning. Let's take a step back and go slower. So the model that we're really looking to build as we operationalize is one of a mental framework more than a technological framework, in the sense of we want to be able to look across the entirety of the development life cycle, all the way from the earliest sort of design conception phases of a new system, all the way out to ongoing deployment and maintenance and fine-tuning and adjustment, and think about the full range of questions that we ought to be asking. And so specifically on this issue of understanding of the functions of in essence, a black box system and our ability to either interrogate that system as it's being developed and built and deployed, or being able to ask questions at the end state. I think what we're trying to tackle is having a different framework that's based upon understanding how explanation is a human-focused concept, and it's one that really has very, very different answers depending upon where you are in that life cycle and depending upon who it is that needs the explanation. So it's a long way of saying, in essence, what we're trying to do is sort of completely shift the approach to development to be one that's more about questioning and human-focused. The HCI element of this in what we're doing now is so critical because ultimately producing useful explanations is very much, again, a human exercise, and it is entirely audience dependent and purpose dependent. And so what it means is there has to be this agility and ability to look for different methods across the board. I love the counterfactual example because it provides such a fantastic way of addressing certain issues that we see when we're building models and we're trying to question the model behavior and we're trying to make sense of outcomes. But I think the people who are closest to that on the inside for us very much recognize, hey, this is a tool and it's a specific tool and it does some things very well. I think as Brent was describing, there are certain things that it won't help you with. It won't help you understand what the system didn't consider or what's outside. And that doesn't mean you get a free pass. You can't say, hey, I use counterfactual as a method. And I do it in every engineering process so I can show the world that I do this consistently and thoughtfully. That doesn't end the analysis. It's like, okay, so what else is going on here and what do you need to understand? I think the real challenge right now for those of us in industry is to be able to have this sort of dialogue and broaden out the conversation to be holistic and all-encompassing and more human-focused in a way that both demonstrates that we don't have the answers, and I don't think we would claim to have the answers in anything resembling the near term. What that is in this space, I don't know, but about as far out as I can see is the next couple of years, and as these issues continue to cycle, especially in the regulatory context, I think the most important thing that we can do is just be open and honest about how we're even tackling the problems, which is itself, I think, an aspect of transparency. And as that dialogue continues, partnerships with policymakers, partnerships with academia, civil society, and really taking these through some specific case studies that illustrate the challenges, what works, what doesn't work, that's kind of where we are today. And I think that's the most important thing that, from an industry perspective, we can be doing with the users of the technology.
I have tons, but other folks want to jump in on the specifics first? Or no? Please.
Yeah, I could jump in quickly. Just from Michael's comments, it seems like the way forward is to have essentially toolkits where you have lots of different methods, but also lots of different, let's say, metrics. We had the discussion of essentially contested concepts before. We shouldn't expect to, say, resolve fairness. I've seen that in some AI ethics initiatives recently. The idea seems to be we just need to figure out all the possible definitions of fairness, compare them to each other somehow, and then resolve them in specific contexts. You should expect plurality. You need toolkits.
Well, because fairness is obviously a mathematical concept.
Obviously, yes.
No, like you, I've been to those conferences where you just scratch your head for a moment and go, really? But sorry, go ahead.
Oh, no, that's okay. I'll end there.
Deirdre, others, or not yet?
I guess one of the things that I think is interesting is to think about what needs to be done up front and what needs to be done at runtime. And like when you think about a concept like fairness, yes, it's going to be operationalized not just within a system, but within a socio-technical system. But in order to do it, one needs hooks in the technical system, right? So you can imagine it needs to accommodate different kinds of contestation, or whether it's procedural views of fairness, or which might require certain kinds of data or reasoning and justifications to be exposed, or if it's, how do we actually want to operationalize this particular measure of fairness, right? Pauline was talking about, is it equalized odds? Is it equal false positive? Like, what is it that you want to, how do you want to operationalize that goal that you have? And so I think there's a kind of pretty rich mapping exercise that's required to think about the ways in which systems need to be configurable and contestable in real time in order to figure out what sorts of hooks one might need to build into the actual technical infrastructure. And so I do think that case studies provide us with some of the rich knowledge, but I think a lot of it, there's a demand problem. I'm sure many of you are familiar with the Bronis and Goodman piece, which looked at the ways in which local governments were acquiring machine learning systems, and basically find, they're acquiring them like they're commercial off-the-shelf products with very little attention to even to exactly what are they doing and what data were they trained on and how are they, right? Like all of those things just don't seem to be apparent in any meaningful way. And so to me, I think that I don't expect that companies are going to build things that the market doesn't demand. We always have this problem. And so I think kind of pushing for governance practices and regulations that encourage people who are deciding they want to use these tools to use them in ways that are consistent with their responsibilities is a really important part of the dynamic, because otherwise you're going to spend a lot of time building things that there's no market demand for.
Right, and rightly so. No, and to your point, so much of this exercise, again, and to Brent's point too about toolkits, I mean, what we've been encouraging people again to think about is toolkits in the sense of, even again, and probably overstate this, but this notion of part of your toolkit is your mental framework for addressing and thinking about the issues. And so again, you know, if you're in a design phase, asking questions even about why you're building the system to begin with. Are there elements of your problem statement that itself should be revealing to you that you've made assumptions about a problem, or you're defining a problem in a way that could suggest that there's a particular bias there that you may not have been directly aware of, but that might surface? Or as you build out and collect data for a specific purpose, are you thinking fully and comprehensively about the ways that you know, bias can creep in, whether it's because the data itself comes from arguably a biased source, or because you've made mistakes in sampling. And including that in that toolkit and that framework is really important. Again, not just to get to a point where you can say, hey, I've thought comprehensively, but to the point about regulation and ensuring that people deal with these responsibilities. Again, I just don't think there will be a way to say, hey, I've met my responsibilities and I'm compliant with a particular law because I've used a tool, or I've employed, you know, certain life cycle management technique that makes sure somebody looks at this. It's got to be this more comprehensive model. And so that I think is going to be really useful. Something Andrew said in the prior session also I think was very relevant here, and it's again on this concept of impact assessments, AI impact assessments or algorithmic impact assessments. The reason I think they're so valuable is not even so much as an artifact or something to look to address or try to unpack problems after they occur, but it forces the process. Exactly. And so the more robust those are, I think the better off the builder of the technology will be, the user of the technology will be, those who are impacted. Because in essence, it sort of creates this very open and broad documentation of all of these critical question sets. And maybe just to take that back and to close on the case study example, back to the Loomis case, the Partnership on AI just last week published a really nice report, I think, on...
Shout out to Josh.
Yeah. We'll give Josh the credit right up there that was prompted by California's SB 10, but ultimately became a report more broadly about the use of automated assessment tools, risk assessment tools in criminal justice. And the reason, the main, I love it for a number of reasons. One is because even internally, it gives us such a beautiful model now to show people, hey, we've been telling you that, you know, these issues of fairness or understanding or user training are important and they're complicated. Here's kind of an example that you can look through to see that, yeah, you know, you've got questions of fairness. It doesn't end by analyzing the data. There are other elements to this. And your obligation doesn't end when you deliver a system that you feel like you've accompanied with appropriate documentation. That system then has to come with an obligation to train and inform and question and maybe decide, look, ultimately we don't have confidence that those who are tasked with using the system can really question it, have the ability to understand confidence levels, or have the ability to challenge, or have the ability even to have a basic understanding of trade-offs between accuracy and different measurements. And so those are the sorts of things that sort of a case study, I think, does so well. It starts to take some of these concepts, which are arguably somewhat theoretical, and make them very real. And in that sense, again, I think this report's fantastic.
So I'm going to try and
Can
tie
I
a
say
ton
just one
here.
little thing?
You want to jump in?
Yeah, well, just, you know, we've had experience with privacy impact assessments, and I did some, you know, work looking at just the quality of them. And I think people have this idea that if we put a decisional tool out there, it's going to like rock the world. And whether you look at, you know, privacy impact assessments, or you look at work like at the IETF, where people had to do security impact, right? Security reviews of protocols. Until you actually have people who have the right set of knowledge, those tools are not really going to produce what you want, right? And so what's really important is getting people who have the right knowledge base and the right incentives within the organization, because they've been told they have to do certain kinds of measurements. And if you're only doing one and you're not doing the other, the outputs are not really that good.
So on that wavelength, going back to what Tom started with, it's a lovely example. But at the same time, I'm thinking, okay, so let's suppose the more than one engineer, which is a great point, and oddly gratifying, because way back when I was in-house at a startup, I realized never talk to one engineer alone, especially as a lawyer, because they just assume you're an idiot, you don't get it, I don't want to change what I did. If I put two in a room and I posed it as a problem to be solved, that was fresh meat. And they would go at it like this to say, well, wait, no, I can do this. And all of a sudden, with a little bit of why, I'd say, well, because, you know, it's 100% cool, but there's a chance that if you only made it 98% cool, it's not as likely to get turned off once you release it to the world. That usually gets their attention. You can't always make that claim. But it was interesting to see that. But at the same time, I'm following your lead here, and I'm thinking, okay, so what if they said, yeah, I gave some kids more because it turns out they're hungry or poor. Now, one, is that something I think maybe you can code that and continually show those? If I remember, my friends at Google did say that in theory, there's a whole thing about being able to have someone else look at your code and know what was in there, and you can even put text like, here's what I'm thinking. The lawyers will start to go, I don't want to see that in my code, please. Do I want to trust 2 engineers to have enough knowledge of ethics and the world? Not a chance. Because it tends to be a utilitarian mathematical world trying to do that. So the things that I would say in terms of going forward, drawing on all sorts of weird things I've done, I think the idea of product counsel is a big thing that should be embraced more, and that perhaps law schools, there was a nice op-ed in the New York Times a few months ago that said the 2 major codes that people need to know are the Constitution, which I take to mean law, and CS. Now, I am truly the unfrozen caveman lawyer. Josh was riffing on my favorite joke. I did rhetoric. I know squat. But then I figured if I'm going to be in this world, I read as much as I can. I think to Deirdre's point, getting lawyers who actually aren't just antagonistic but understand it and look at the words bias as, well, we have built-in problems as opposed to you're clearly a racist, which, by the way, that tenor, I do think some of the criticisms early, data is discriminatory, it's not. It has huge flaws. Reifying things. These things cause real friction and walls from the computer science world and the business world. But then bringing in people during the whole process and after, right, continuous. So this actually brought to something that Harry and I talked about is there's a great, Peter Dominguez's book on machine learning is fantastic and very eminently readable by those of us who are not tech. And one of the big points was exploration and exploitation. So a lot of these systems, it seems to me, what's happening is people are just deferring. It was built, I can rely, I can cover my ass, right? The CYA moment. I bought it, it was by someone who said it was good, and now I can do my bureaucracy, even though it's criminal justice, and boy, shouldn't I have done more there? But no, I bought it. And so the odd part is, I think if we embrace the notion of learning, which is an ongoing back and forth in CS, right, in machine learning, that could break through what I would call a certain complacency, perhaps, right, and or deference, right, which worked really well, and this is where I'll pick on my former part-time employer for a couple years, in the Google early days, right, because those were easy wins. Wow, we have a system that solved all sorts of informational problems, right? Yahoo directory, forget it, doesn't scale. And it was like, oh, well, we can use that for everything. Huh? Wildly different as we started the morning talking about. But it was big data and Victor Meyer-Schoenberger. We don't need to know why. Actually, we do, right? Sort of. But the ongoing vigilance and learning, and this is where I think what you were talking about really captured that. Think about the kids. Like, they have to have at least some feedback and explanation and persuasion. And I'm going to go way out there at this point. This is also true for our democracy, right? You have to continually explain why. That is, in theory, the way the system works. It's weird. It's broken. It has, as professors today have said, moments where it looks like it's just running the process. But in theory, we all get to look at it, and sooner or later, judges get to say, I disagree. Law professors get to say, I disagree. And we might have debates that work, but it's the complacency, to my mind. And what I think is this group is really saying there are many different ways to not be that complacent, but I think you have to have all of them, up front, during, and after. And there's so many different layers to that. But those are, I think, viable, as you say, to have hooks on what you mean by why you want to contest. And it doesn't have to be fully explainable to still go, how did you get that outcome? And now it is time for, I get to double check, are there any students who are hopefully playing hooky-ish? Okay, you don't have to identify it that way, but go ahead, students. Oh, you're our mic man, or you have a question as well? Oh.
Both Mike Man and was hoping to ask a question, and I'm not playing hooky. So I'm not sure if you're familiar with the ruling in Sandvig v. Sessions that created First Amendment protected carve-outs in the Computer Fraud and Abuse Act for individual researchers and journalists who misrepresent their demographic profiles in order to conduct research on potentially discriminatory algorithms on social media platforms and whatnot online. And I was curious if you think that that's an effective and B, appropriate mechanism for achieving some of the transparency or auditability that we've heard discussed a lot today? And if so, how that could be improved upon as a mechanism or applied potentially in jurisdictions without such strong First Amendment protections?
Okay, having moved to a B school, I've missed that one.
There are many ways in which existing law gets in the way of research that is important for security and also important for things like doing the sort of like, A/B testing that have been a traditional part of ferreting out discrimination historically. And I think that there's a bunch of research reports. One that I did with the support of the National Science Foundation some years ago, where we pulled together a bunch of computer security experts in particular, and we produced a document just talking about the ways in which current law creates barriers to cybersecurity research, but those same barriers even more so because for cybersecurity there are some specific carve-outs. While they're much too limited, there are some specific carve-outs that kind of like fairness researchers wouldn't necessarily benefit from. So I think as a general matter, there's been a hope that prosecutors would be strategic about who they decided to go after. But I think that has a chilling effect on research, in part because large universities are often risk averse, and it also, if you're advising your junior researcher, you might say, well, it turns out there's some legal risk if you go that way, so maybe you should direct your research this way. Some of the journals, their processes are really timid also about people who might have done something that could be arguably a violation of law. So there's lots of ways in which I think research that would be kind of the adversarial testing of systems is stymied by law. But I would say that I think that research only gets us so far, in part because what it really is like counterfactual research. And I think that there's enormous limits to thinking about interrogating systems from that external-only perspective.
Yeah, to build on that, and I think actually this was in the PAI report as well, Josh, this notion of, for certain types of systems in certain domains, really ensuring that as part of the development process, that what's built into that is the ability to do third-party testing and auditing in an independent fashion, right? I mean, there will always be, I guess, this tension between opening up the system to just any sort of adversarial attack and from any quarter. On the other hand, if it's too limited and constrained, it becomes sort of a less useful exercise at a minimum. But I do think, again, that there's the right dialogue should be around, all right, whether it's providing protections through CFAA adjustments. I know we've talked, Ryan Kalo in my neck in the woods up in the Seattle area has talked quite a bit about the potential to do something there. I'm kind of with you, Deirdre. I worry that, again, we may be finding ways to try and open up and provide some more freedom, but you'll still have problems with just feeling safe in doing that. And I think it also sort of takes away some more of the responsibility that should be on the developers to think about ways to ensure this stuff can be tested and poked at a minimum by an external community. Go ahead, Tom.
I have a true story I would like to share. It's kind of about putting two engineers together to work on the project, related to what you said. So I got this email from two engineers, put together this really wonderful online education tool. It's a website and asked me for feedback and designing for early childhood education for young children, like age 6 to 8. So I looked at it was pretty cool. And I became curious. I actually I went into the terms of services and read online privacy statements. So I had this nugget. It goes like, oh, for children online, privacy protection, this website is not designed for 13 years old and younger. If we discover any child under the age of 13 will voluntarily take out all information. So what this illustrate is that, so there's one side is like this legal requirement, and it creates like a minimum, kind of like a minimum requirement that engineer might be tempted to just put that legal disclaimer, but they still go about and do your own thing.
Yeah, that's not going to work out well for them, just to be clear.
Okay, we only have 5 minutes, and I saw at least 1, 2, 3, 4 hands. So, oh, 5. All right. So how about, can you all discipline yourself to 30 seconds power talk, and then we'll see what happens. We'll give it a go. So it was roughly in the order of, it was 1, 2, I saw 3, 4, 5. Sorry, Pauline. And I will go with that.
Yikes. My T-shirt question, technology fits so well into these questions. And I audit elections professionally. And I think that there are some real interesting connections that you've all just started talking about if you don't trust computers, we have a concept of software independence. How can the election system kind of demonstrate that the results are right with paper ballots and samples and stuff? So are there sectors in which that kind of approach might work? Are people doing things like that? How might you work that in?
You want me to
power it?
You want to just keep going. So I have a question for Mr. Phillips. Microsoft has announced that there's an AI ethics review contemplated as essentially a checklist of audits to be added to a checklist of audits, which I think is a good thing. I'd like you to speak to it, but I'd also like you to speak to whether you would be open as a corporation to addressing what Professor Kaminsky is writing about in her article on binary governance, which is to have third parties or independent auditing of what corporations are doing. So the question being is, who guards the guardians?
Mm-hmm. Okay. Now we have this right there.
Hi, my question's for everyone, but specifically for Ms. Bryant. In your work specifically, what have you seen that fits the needs for explainability, but in a way that's accessible, especially for an audience like children, and what kind of strategies and balance have you seen that work between being thorough in the explanation and also not overwhelming the audience?
Hi, so I'm a middle and high school teacher over at Lotus School for Excellence. It's a very diverse group of kids. And I'm trying to bring artificial intelligence into the curriculum in that school. That's one of my #1 goals. And I see that problem that you were talking about, Tom, with that disconnection with engineers and ethics being isolated. So I want to bring that to the kids early on. I guess I'm just trying to figure out how to do that as a goal.
Pauline? Okay. Let's go then very quick, right from the beginning. Anyone think that there are other sectors similar to voting?
Voting is a great, so Josh and I both spent a lot of time working on voting systems, and we see some of the similar issues, right? So we were talking about testing. As you know, the voting systems get delivered, and at least when I was working on voting systems, the only kind of testing you were allowed to do was logic and accuracy testing. Couldn't test the security, but things like ballots, right? We talk about software independence, but it took a long time for David Wagner and others to come up with the concept of software independence. The law didn't say a ballot has to be a fixed thing that doesn't undergo additional processing, right? So there was a bunch of legal work that needed to be done in order to get the voting machines we wanted. And so I think there's a lot of great stuff to be drawn from voting. Not that voting got it all right, surely not, but there's a lot of great lessons that are all too similar in a painful way.
Takes us down to, we lost. All right, it is 4:10, and out of deference to our hosts who have clearly.
As co-host, I actually want to hear Ms. Bryant's response.
Yeah.
Oh, okay. You get to trump. I like it.
So definitely some things that we've seen that have been successful are using multimodal ways to express explanation. So sometimes we'll have a tablet, and so what is going on, it'll do some visual explanation, as well as we have investigated different types of verbal communication based on their emotional state. So depending on how we perceive them to be, what state they're in, have that also influence how we deliver an explanation, whether it be short, maybe it needs to be a little longer, they look confused, we need to go a little deeper, or we need to hang back some. So taking into account what state they're in, as well as different ways that we can actually show an explanation, have shown great promise.
With that, before we hand off, please, everyone, I think, thank you.
Well, thank you, Devin, for a great panel. And I want to thank you guys all for coming today. I think this has been a tremendous conference. I learned a lot. I hope you learned a lot. I also want to once again thank our great Silicon Flatiron staff who worked so hard to put this together. I want to thank my colleague Margot Kaminsky, who worked so hard to put this together. I want to thank our volunteer students who were, in the middle of study season, volunteered to come here, maybe even play hooky. So thank them for all their hard work. Our sponsors, especially Microsoft, for sponsoring the reception. And last but not least, our amazing moderators and panelists who came far and wide and made this the conference it was. So thank you so much. Thus closes the Silicon Flatiron's academic year programming. We will see you guys in the fall with a new suite of conferences. So thanks so much. Thanks, David.
Okay, yeah.